Hello everyone, and welcome back to another card game tutorial video. In this video we will go over how to form a perfect arc for your hand cards using trigonometry. This will allow your game to emulate a more realistic way a player would hold their cards. In the next video we're going to work on how to select those cards after forming that arc. When you begin rotating sprites, you'll find that the collision mask begins to change. So we'll need to address that in order to continue playing these cards. If you enjoy this series, be sure to like, comment, and subscribe. If you want to support this series and download these program files, be sure to check out my Patreon, linked in the description below. Also linked in the description is a Discord server you can use to talk to me and other card game creators for help and assistance. Now, before adding this to our game, we are going to hijack our menu screen and print a sample hand using the trigonometric calculations I'm about to go over. This will be easier to test since we do not have to connect to a server or another player. The first thing we are going to do is going to be in our menu object create event. We will initialize a hand count variable to 0 and initialize the sprite array. Next, we'll go to our step event and add a condition that if the left mouse button is released, we will increment the hand count variable by 1. So what we're going to do is we're going to set the depth of this menu object to be above everything else. Then we're going to want to draw the field sprite to emulate that we're in a battle. Next, we're going to create a local variable for the radius of a circle that we're going to draw in the center of the field. And I'm going to set the radius to be half of the room height. This can be any size. If you need a greater arc, draw a larger circle. If your circle does not fit in your room, be sure to offset where you want to draw it and include that offset in your calculations. If you need help with that, be sure to check out the Discord linked in the description below. The next local variable we're going to create is going to be the angle difference at which we're going to draw our cards. And this is going to follow a specific equation for the angle of an arc on a circle. So I'm going to comment what that equation is. And then I'm going to call that variable delta. And the arc length you want to choose, I recommend to be less than your card width, but you can make it any value you want. Test out different lengths and see what looks best for you. But the length I'm going to go with is going to be 2/3 of my card width. And be sure to look up these equations if you want to know more about them. Now, with these two values, we can draw the circle to our room. And I want that to be in the middle of the room. So now, before going any further, let's make sure that this circle creates the arc we're looking for. So as you can see, the circle doesn't fit in the room width-wise, but it does height-wise. And when we begin drawing our hand, it's going to follow this line all around the circle. And what we're going to want to do is we want to choose a max arc length at which our cards will be drawn on. If we don't, the cards will be drawn around the entire circle. I found an arc length of 10 cards drawn at an angle of 2/3 of the card width apart is the perfect space for my hand. To make sure our hand is printed in this space, we will use the following conditions. So what we're going to do is we're going to create another local variable, and we're going to call it j. And j multiplied by the angle we calculated, delta, will give us the angle of the card we're drawing. So I'm going to add that in a comment so we do not forget. And this will make more sense in just a moment. So if hand count is less than or equal to 10, because remember the distance that I want is of 10 cards. So this is what I'm going to do when I have 10 or less cards. I'm going to set j equal to negative hand count minus 1 divided by 2. Now this value is going to tell us here where to begin printing the first card. So now when our hand count is greater than 10, we're going to set j equal to that same spot as this j if our hand count was 10. So I can put the numerical value for it, but just so we don't forget, I'm just going to plug 10 into the equation like this. And that's what we'll need to do to determine the starting point of where we draw our hand. So now we can draw our hand, and what we're going to do is use a for loop. We're going to set a local variable I to equal 0, and if I is less than hand count, we're going to do the following code, incrementing it by 1 every time. So we're going to draw the card sprite, and we're going to set all of our card sprites equal to the card back. And then we will draw that sprite. But before we do that, I want to continue working with the j variable. As we go through drawing all of the cards, we will need to increment this a specific way underneath the drawSprite extension function call. We will need the following conditions. Inside this for loop, we're going to say if hand count is less than or equal to 10, we're going to increment j by 1. So what that will do, we'll print the next card one whole card distance apart from the one prior. Now, if our hand count is greater than 10, what we're going to do is we're going to squeeze the next card within an arc of 10 whole cards. And what this will do is effectively fit our hand always within the span of 10 cards. The cards in our hand will fan out more than we want if we leave this at 10. I found the perfect distance to be 9.5. So now we can draw the card sprites. The challenge here will be getting the right X and Y values and the angle at which to rotate the card. Luckily, they all will be functions of the delta variable we created and the J value. So in the draw sprite extension function, we'll have the following values. We're going to draw the card sprite at its first subimage. We need to determine what the X value will be and the Y value. The X and Y scale will be 1, and the rotation of this card will be J times delta. So that's how you'll get it, all the cards to indent towards the middle. Then we want the color to be its regular color and the alpha to be 1. Now the X and Y values will be relative to the center of the room. From there we will use right angle triangle calculations to determine X and Y. We have the hypotenuse of the triangle, which will be the radius of the circle, and the angle of the triangle at the center of the room, which will be J times delta. The X value will be the opposite leg of the triangle, and the Y value will be the adjacent leg. So the opposite leg of the triangle will be the hypotenuse multiplied by the sine of that J times delta angle. So what we can do is go to our X value and replace it with radius times sine. We're going to use a function called degree to radians of J times delta. And that's because the equation we did here gives us the value in degrees, but the sine function needs the input to be in radians. Now the X value needs to incorporate the room width, so we'll change the X value to be room width plus radius times the sine of that angle. So now if we left it like this and we had the circle drawn here, the cards will be drawn at the bottommost part of the circle, and that arc will make more of a U shape, but we want it to follow the arc at the top of the circle. So what we'll need to do is, in the sine function and the degree to radians function call, we'll need to add it by 180 degrees to make it go to the top. Now the Y value will be exactly the same, except instead of sine it will be cosine, and instead of room width it will be room height. So we're going to take this and we're going to copy it and paste it here. We're going to change room width to room height, and we want to divide that by 2, and we also want to divide the room width here by 2 as well. And then instead of sine it'll be cosine. So now if we test this and we start to click our mouse button, you'll see that we now have cards drawn at the top of the circle. But that's not where we want our hand to be as the player. We actually want it to be underneath our field here. So the next thing we'll need to do is find a way to move our hand from the very top all the way down to the very bottom, or at least just below our bench. And if we keep clicking till we get 10 cards, you'll see that this is our max hand before we start truncating the cards in our hand. So if I do another click, you'll see that now all the cards will kind of shift towards the middle. As you can see, this one got closer, but this one stayed in its same place. So if I keep clicking, you'll see this one stays in its same place, but this one begins to fan out. And this is why we wanted to choose a value less than 10 when incrementing our J value. Because if we did, it would begin to fan out a little too far. And if we keep clicking and clicking and clicking, we'll see that it stays within this boundary and it doesn't really go too far out. So now in order to get it to be drawn towards the bottom, you may need to play around with it to get it to the exact position you need, but all you need to do is manipulate its Y position. And I found the best spot for it to be is to be 91% of the diameter, which is the radius times 2. So now if we take another look at it, you'll see that now my hand is drawn just beneath my bench. So now that we can see the theory in practice, we need to add it to our game. And the trick behind that is doing it like this, we can account for everything in the same object, but each card is its individual object. So it will need to calculate its delta and its position on the field separately from all the other ones. Now, before we do that, we want to copy everything we put in our menu object draw event. We're going to copy it, and then we're going to remove it. And then we're going to remove everything else we added in our menu object. And then we're going to go to our card object in the step event, and where it says card in hand equals true, we're going to remove the calculations for the X positions because we're going to add new calculations of where we want the card to be. And this is where we are going to paste everything we copied from the menu object. So, like I said before, we need to adjust the calculation for our J variable. Since it now needs to calculate it separately from each other. So what we'll need to do for that is, in our calculations, what we're going to do is we're going to incorporate the hand position of the card that we're calculating it for. So what we're going to do is we're going to do hand position minus the player hand count minus 1 divided by 2. Now, since we're not going to be using this for loop here, we need to incorporate this specific incrementation in our calculation for J. So what we need to do is we need to take this value here and we're going to paste it here. And then we're going to remove this if-else statement and this for loop. But we're going to keep the draw sprite extension for the time being. So what we need to do here is we know that this value right here is going to be 4.5. So what I'm going to do is I'm going to put 4.5 and then I want to add the hand position of this card, and I'm going to multiply that by this 9.5 divided by hand count, like this. And that will effectively incorporate that j incrementation from that if-else statement we just deleted. But now we don't need to draw this sprite extension because the object is already drawing itself. What we need to do is we need to calculate its x and y positions. So we're going to do x position equals some value and y position is equal to some value. And that value is going to be the same value here for this x and y position. So all we need to do is copy and paste that here. And now we can delete this draw sprite extension. But one thing we haven't included in here was the image angle. In the draw sprite extension function call, it had an input for that image rotation. But now, since we're not using that to draw this object's sprite, we need to do that ourselves. So what we're going to do is, if alarm 1 is greater than -1, which means it is being drawn, or if the card is selected, we want its image angle to equal 0. Now, other than that, we want its image angle to equal j times delta. And then, with these calculated points, this step event will move the card to those new positions we've just calculated. Now, we also do not want this depth here anymore. And we don't need the field sprite being drawn, so we're going to remove those as well. And this should be everything we need. But we do need, for all of the player variables, like hand count, we need to add the object pointer. So let's make sure that all of the hand count variables have the player pointer attached to them. So it's here, it's here, it's here. And I believe that's all of the positions. So now, if I were to load the game up, we should see that the player's hand cards are now being drawn in an arc. So if I click continue, we'll see that they're all, we can see that the cards aren't actually being drawn the way they need to be. So if we look at our X and Y calculations, let's see where we went wrong here. So these are right, and this is right. I'm assuming the problem is going to be in here. So what the problem is in our player hand count, when we have less than 10 cards, we messed up the calculation for J. We forgot to add a parenthesis here because we wanted the player hand count minus 1 divided by 2. Because if you remember, in our menu object, we had this. So we needed to put this value right here. And forgetting that parenthesis messed up the equation. Then we need to close off this parenthesis here to make this whole thing negative. And we also messed up the J calculation here. If you remember, in our menu object, we had this value, which is supposed to represent this value here, this 4.5. But we didn't drag over the negative. And then when we combined this value with the incrementation of J, which looked like this, we took this value here and we put it at the end here. Now, the problem is we deleted these three characters, but that isn't the same mathematical equation. What we needed to do is remove these three characters, because 9.5 times 1 divided by hand count is the same as 9.5 divided by hand count. So we need to change this from multiplication to division. So now if we remove all of this, we can retest our game. So if we hit continue, you'll see that the image angle is 0 until the card is drawn into our hand. So as you can see, it follows that perfect length. But now let's see what happens when we draw more than 10 cards. So we have 1, 2, 3, 4, 5, 6, 7, 10. So now let's see what happens when we draw one more card. As you can see, all of the cards shift closer to the left side, and it should remain doing that until we draw all of our cards, and it'll begin squeezing all of them together. Now what we're going to do in the next video is, as you can see, it might be pretty easy for me to select some of these cards, but as the image angle gets a little larger, as you can see, I'm selecting on Polyrath, but I'm picking up Squirtle. So we're going to fix that in the next video. So if you're interested in that, be sure to subscribe. But before we end this video, I want the opponent to have the same arc that I have, just so it'll be a perfect mirror. And that'll be very easy. All we have to do is copy everything we did here and paste it in our opponent card object. We need to remove the X position calculations like we did before. And we're going to paste it here. Now, the difference from the opponent object and our object is we want it to follow the bottom arc of the circle. So what we need to do is we need to remove this 180 degrees from our calculations. And we also want to change the Y calculation from adding 91% of the diameter to subtracting it. So now if we test this, we should see that the opponent also has an arc in their hand. So if I hit the continue button, we'll see that the opponent now has an arc in their hand as well. As you can see, it follows it through. And let's make sure that if it has more than 10 cards, it follows the same format as our player object cards. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And as you can see, it also begins to shift the cards in one direction. So that's all I wanted to go over in this video. If you enjoyed the series, be sure to like, comment, and subscribe. If you want to support the series and download these program files, be sure to check out my Patreon linked in the description below. If you're having any problems and you want to talk them out, be sure to check out the Discord. That'll also be linked in the description below. Until next time.